What is the Coriolis effect?
It's when objects are deflected.
Can I say it, mister?
She did. Okay, so when objects are deflected, so what way are they deflected in the northern hemisphere? Okay. Clockwise. And then in the southern hemisphere, it's counterclockwise, okay? Good. Next question, guys.
Why is the Coriolis effect so important?
What's that?
Why is the Coriolis effect so important? Why do you think it's important? Tanya, why do you think it's important?
Should I get a check for asking him a question?
No, because you guys are leading the discussion. So, if we didn't know or understand about the Coriolis effect, would that make it harder to fly places?
Yes.
Yeah, okay. So, what about if we take it one step further? What if we know that there's a tornado or bad weather coming in? Can we use our knowledge of the Coriolis effect to predict where it's going to go?
Yeah.
Yeah, because it's going to deflect a certain way, whether it's in the northern or southern hemisphere. Okay? So we can use that information to predict changes in weather and if a storm's going to hit us or anything like that. Okay? So that's why it's an important thing to understand.
What could change the movement of the Coriolis effect?
What could do what?
What could change the movement of the Coriolis effect?
Okay, so what changes the movement?
Forces.
The forces, and where do we see these forces? In
Equator.
the equator, okay? So if it's in the northern hemisphere, the forces are going to change, and if it's in the southern, the forces are going to change, and that's all due to the rotation of the Earth, okay? So the Earth is spinning, so we're going to have different forces in different hemispheres. Are we good on that one? Good. Next question,
Is
guys.
there any other way to demonstrate the Coriolis effect?
So what's an example? How do we show the Coriolis effect? What could we do?
With the water and
Going to the other side of the
Water in the toothpick, that flushing the toilets? What else?
Oh, what's that thing when they were at the southern hemisphere? No, but when they were at
The equator?
yeah.
And what happened at the equator?
Move.
It didn't move because the forces balanced each other. What's another way we can show an example of the Coriolis effect? The airplane, the actual path and the projected path. What about the example at the playground? What happened there? What were they doing? Spinning on the merry-go-round and throwing the ball, right? And he wanted to throw it to his partner straight across, but since they were spinning, it actually deflected this way and his partner ended up that way, right? So that's another example that we can use to show this is going on, okay? Keep going, guys.
When looking at weather patterns, is it easier to make predictions knowing what you know about the Coriolis effect? Why or why not?
Wait, what?
When looking at weather patterns, is it easier to make predictions knowing what you know now about the Coriolis effect?
Yeah, because you know where the wind's taking starts.
Exactly, good. Okay, next question, guys.
Oh, can you give us an example of the Coriolis effect?
the airplane.
An airplane, that's a good example.
Ball.
Throwing a ball. Just throwing a ball, or does something have to be going on? So you have to be spinning, okay? So right now, because the Earth is so big, us just throwing a ball isn't going to demonstrate it, okay? But if we're spinning, it's going to demonstrate it. So we have to recreate the movement of the Earth because we're not big enough to demonstrate that, okay? But in a plane, when we actually get in the air and we're moving, does the Earth stop while we're in the air? It's still moving too, and that's why we can demonstrate it through flight patterns and things like that, okay? All right, good job.
We have the fourth.
Oh, that's it?
Nope, me and Chris are